In the last video, we looked at the concept of logic gates, which are the main building blocks of Boolean logic. In this video, we'll be looking at something called a truth table, which is the way we show outputs for all possible inputs of a logic gate arrangement. On this slide, you can see that we have two empty tables. Now, the bottom sections of these tables, from the rows that say A, B, C downwards, are the truth tables. Now, they're empty at the moment. These truth tables will be for the AND and OR gates that we learnt about in the last video. Now, as I said earlier, we use a truth table to show all the possible different outputs of a gate when comparing it to all the different possible combinations of inputs that the gate can have. Now, we're going to be using two input gates here, so gates with two inputs. So therefore, two inputs per gate, two possible values per input will end up with four different possible combinations of inputs. And so we're going to look at the moment at the AND gate. Now, if we can remember from last time, the way to draw an AND gate is two lines going in for the inputs, then a semicircle, and with a line going out for the output. Now we're going to name our two inputs A and B, and then our output is going to be C, hence the labels down here. Okay, so A, B, and C. So obviously you can guess our inputs are going to be in this section of the table here. Now, obviously we know in Boolean logic you can only have a 1 or a 0 for each input. So I'm going to go through this line by line. So in no particular order, we could have a 1 for input A. We could also have a 1 for input B. And another combination could be a 1 for input A and a 0 for input B. Then we could flip it and say a 0 for input A and a 1 for input B. And then obviously we could have a 0 for both inputs. Now thinking back to the rules of an AND gate, when all inputs of the gate are true, only then will the output return true. So therefore, this first row here will return 1. Now, if we look at all of the other rows in this truth table, you will see 1, 0, there is a 0, so we can't do that. 0, 1, there's a 0, and then 0, 0 is both zeros. So therefore, only one row of this truth table will actually return a true output. Moving on to the other side of the slide now, to the OR gate. Now, if we can remember, again, it's similar in the sense that we put the two lines for the inputs, but then it's kind of like a curved line along those, and then a more pointed. It's not very good because of my handwriting, unfortunately, but there will be a printed version later on. So again, we're going to be calling, and sorry, there's a line as well for the output. We're going to be calling our inputs A and B, and again our output C, and of course, just like the AND, it's like that. Now, because our inputs are A and B, obviously our inputs are going to be going in this section of the truth table. And again, we can, because this is a two input gate, we can actually just copy across the different combinations of outputs that we that we have here. So we've got 1 and 1, 1 and 0, 0 and 1, and 0 and 0. Now, you can remember from the last video, the combination that makes an OR gate return true, the rule that runs with an OR gate is at least one input has to be true. So not both. It doesn't have to be both, but it can be both. At least one, so that's one or more. So we look here for column C. We look across 1 or 1, well, at least one of them is true. So therefore, the output will be true. We look at then 1, 0. at least one, again, one input is true. That'll be 1. And then the next row, obviously, it's pretty much the same. It's just the other way round. So therefore, at least 1 is true, and the output will be 1. The only row that actually rings false here is 0 and 0 or 0. This is because there are no positive inputs coming into the gate, and therefore the rules of the OR gate haven't been satisfied, and therefore we output a 0. And here are the neatly completed versions of the truth tables. Now, these are very important for your exam. You have to know how they work because you have to be able to recognize what gate you're looking at from your truth table that you're given. For example, the exam question could say, here is a truth table, what gate is this representing? And it might be this truth table here, and it might say, what is this representing? Obviously, it would be an AND gate. And then, of course, the same for the OR gate. Now, the gate that we learnt about, the other gate that we learnt about in the last video was the NOT gate. Now, this is a pretty simple one, so it's not going to take too long to go through it. Obviously, we know what we said in the last video was that this is often called an inverter. Basically, it inverts the signal. So, this is our gate here. It's a line going into triangle, which then goes into a circle, which then goes into another line, which is your output line. We're going to call our input A, we're going to call our output C. Now, we're going to look at our inputs here, which is going to be column A. It's very straightforward. Obviously, you're only either going to have 1 or 0, and then we're going to invert. So 1 becomes 0, and 0 becomes 1. And there is a neater version of that for you, so you fully understand. This is a very important concept. Again, NOT gates are one of the probably the most important gate, I would say, in my opinion, because they serve so many purposes and they are vital to a lot of different purposes. If you have any questions on anything covered in this video, please feel free to comment down below and I will get back to you as soon as I possibly can. Again, do not hesitate to ask your computer science teacher about anything you do not understand, as they will be the most reliable source of information. In the next video, we will be combining what we've learnt in this video and the last one, and putting different gates together and completing the truth tables for them, and talking about some of the different scenarios that we could put some of these practices into.